There still seems to be a lot of debate about whether or not climate change is real, but the scientific evidence is actually pretty clear. Many science-based organizations actually believe that the increase in global temperatures that we've been observing over the past several decades is a direct result of greenhouse gas emissions caused by human activity. Now, that's not to say that all greenhouse gas emissions are a bad thing. In the Earth's atmosphere, they act like a giant blanket trapping warm air around the planet. And without them, the Earth would be about 60 degrees cooler than it is right now, too cold for life as we know it. But increased amounts of greenhouse gases in the atmosphere cause that giant blanket to increase in thickness. And warmer temperatures over a long period of time contribute to climate change. Based on ice core samples spanning thousands of years, there's evidence that that warming blanket has increased significantly over the last 250 years, greatly exceeding the levels that existed over the previous 650,000 years. And not all greenhouse gases are created equal. Some of them trap solar radiation much better than others. Most people have heard about carbon dioxide and methane as two of the major contributors of climate change. However, there's also nitrous oxide. Nitrous oxide is produced naturally from biological processes that occur both in the soils and in bodies of water. And left to its own devices, the planet balances itself out nicely. The amount of nitrous oxide remains fairly constant, which contributes to our protective blanket. But too much nitrous oxide is even worse than too much carbon dioxide and methane, because nitrous oxide is a much more potent greenhouse gas than either of the other two, and it remains in the atmosphere for over 100 years. That's definitely a concern in our attempts to mitigate the future effects of climate change. And it's of particular interest to those in the horticulture community because a changing climate will impact what we're able to grow. And growing those crops also contributes to greenhouse gas release. In fact, estimates are that about 70% of the nitrous oxide that's released in the United States come from agricultural activities. Modern agriculture around the world uses a huge amount of nitrogen-based fertilizer, over 100 million tons per year. Plants use only a portion of the fertilizer that's applied to the ground, and the excess has a number of different options. It can stay in the soil, it might leach into the groundwater, might run off into streams and rivers, or it might be converted into nitrous oxide. But we can't just stop using fertilizer, whether it's synthetic or organic, because food production would be really limited without it. And a growing global population needs agriculture to provide increasing amounts of food from limited amounts of land. So you might ask, what can be done? Well, studies are ongoing at research centers and universities around the world, where preliminary findings point to several potential solutions. Promising ideas include more precise fertilizer application, modified soil management, and improved crop breeding. Precision fertilizer management can be as simple as calibrating and maintaining the application equipment, or it can also mean more rigorous planning scenarios involving soil tests, estimating the amount and type of fertilizer that the crop requires, and then optimizing the timing of the fertilizer application to when the plant actually needs it. Other soil management practices can also have a big impact on nitrous oxide emissions. For example, the release of nitrous oxide seems to be greatest in wet, warm, compacted soils. So avoiding any of these situations can thus reduce emissions. Installing tile drains or planning field layouts to include uncultivated areas that are planted with trees, shrubs, or other perennials can help to improve drainage. Using cover crops, compost, and slow-release fertilizers may also help to reduce the loss of excess nitrogen in the soil and thereby reduce the need for additional fertilizer applications. And the breeding of crops that are more efficient at absorbing nitrogen from the soil can potentially reduce the need for nitrogen fertilizer. If you'd like to find out more about this subject or about plants and agricultural practices in general, check out our horticulture classes and programs at Clackamas Community College.